Good afternoon, guys. And today our topic is invertible and non-invertible system. Then we will go for the convolution integral. Okay, for the LTI system. You can see first invertible and non-invertible. Invertible and non-invertible. Invertible and non-invertible system. Say if this system, this is x of t for this continuous system. Actually in your syllabus there is a continuous system, but this is applicable for both continuous or discrete. So if it is a x of t, then output is y of t. This system would be a invertible if we go for reverse action or inverse action, then we again achieve these things. So this system is the inversion. If this is possible, then it is invertible. If this is not possible, then it is told that is non-invertible. Okay, say x of t, if a system is converted into the y of t, this is a system, this is the output. If and only if we take, if we able to design a inversion process which will yield exactly the input of these things, this is the same thing, then only this is called invertible system. If this inversion process is not possible, then this is called non-invertible system. So first we have to see, just you may write down this first few statement. Okay, then we will prove it by an example. If distinct distinct inputs, if distinct inputs produces distinct output, distinct output, then it is called invertible. Say if x of t is always that x of t is the y of t, y of t, say x of t t1, then we get y of t1. If x of t is 2, then we will get y of t2. Okay, so the everything has distinct value. If this these two things are become same, then this is not your non-invertible conditions. Or you may say, so every x set there is a y set which is 1 to 1, 1 to 1 matching, 1 to 1, 1 to 1 mapping. This is not mapped with this, this is not mapped with this. Okay, this is only mapped, this is xt1 is mapped with yt1 only, this is not mapped to other. So in this way you can also say the input can be, or second or another statement, if input input can be determined by measuring the output means if you got this output, then if you inverse, then we get the input. Okay, then the system, or you may say, or another things you may say, that is, if if the system the system following 1-to-1 mapping, then this system is called invertible. Otherwise it is not invertible. So let's see an example, then we can understand these things. Say first example is one, that is y of t equal to 4x of t. Just tell me, is is that system is the system is a invertible or non-invertible? Will or not? Okay, so we have to check for each xt, we have to get a distinct yt. Say t equal to 0. Say then, and just we should get that is xt and that is yt. So if I put 0, then x into 0, x0 is 0, and this is 4. 0 into 4, that is 0. So y also xt is 0, then yt is 0. If t equal to 1, just put this. So t equal to 1, then we get xt equal to 1 and to 4. So if t equal to 1, xt equal to 1, then only we get 1 and then we get 4. If t equal to 2, then this is 2. 2 into 4, that is 8. 8. Okay, if t equal to minus 1, if t equal to minus 1, this is minus 1. If t equal to minus 1 means xt equal to minus 1, then we get minus 1 into 4, that is minus 4. Up to this you can see every x there is a distinct y. Every x there is a distinct y. Okay, so this is invertible, but from this example you couldn't understand these things very properly. Okay, but if I told that another example, that xt example 2, xt equal to just like this 4 of xt, if this is possible, so then t equal to 0, look xt, and this is yt. You can see if t equal to 0, xt equal to 0, 0 into 4, that is 0. Sorry, this is 0, it is already told, so this is will be 0, this will become. Okay, if t equal to 1, then this is 1, 1 into 4. If xt equal to 1, then 1, 1 into 4, that is 4. If t equal to 2, then 2, this is 2, then 2 square equal to 4, 4 into 4, that is 16. If t equal to minus 1, then t equal to minus 1, we will get this is minus 1 square. So this is 1, 1 into 4, that is 4. So guys, you can see for the different input, that is plus 1, that is minus 1, but this input, this output, and this output is same. Is that a invertible or non-invertible? So as per the conditions, these three conditions, you may see the distinct
Sir,
input.
sir,
Yes, yes,
please scroll a little bit upwards.
yes,
No, sir, upward, sir,
upward.
upward, sir, the figure.
This statement, this
No, sir.
statement, this, which one?
Yes, sir, yes, sir.
This statement.
Got, got
Okay,
it, sir. I got it.
if distinct input produces distinct output, is that here you can see distinct input but couldn't produce distinct output. This is 1, that is minus 1, but your output is same. This is not distinct, this is not separate. But here you can see there is a separate 1, this is 4, minus 1, that is, you can see that is minus 4. Okay, minus 1, that is minus 4. So these and these are not same. So distinct input produce distinct output, but here distinct input produces the same output. So this system is not invertible. Okay, so in this way we can understand these things. So again we can say from the very beginning, that just I am saying the first thing over here. If a system is after getting output, if we able to design a inversion process which yields the same thing, then we can say this is the invertible. But here from this 4, by using this 4, you can't say this is 1 or -1, you can't determine. So this things, this statement, if input can be determined by measuring the output, so input is not determined by measuring this output, because 4 it may be from 1, 4 it may be from -1. So this statement is not applicable for here, because this is not invertible. This is not invertible. This is not invertible, non-invertible system. Okay. So, and another thing is there, if there is a mod function is there, say your function of t is equal to x of t mod, then also this system will be coming over there. Okay. And uh, this is your system, and this is called the invertible. This is non-invertible function. Okay. So this is your two types of there. And next topic is that I'm going for the next slide. To check the system, we have to use some test signal. Say some complex system is given. Just like y of t equal to sine t x of t. Look, in this system, this is a unique system. This is another system is there. So whenever they are multiplied, we don't say that is a invertible or non-invertible. Then we have to put some unit unit step signal or unique signal, that is called the step signals, test signal. Sorry, not step. That is test signal. So these are, say, we we can use we can use to test signal when some signals are mixed up. Okay, this one is unit step. You have familiar with this system, that is the unit step signal. So you can use also inverse of unit signal, and it is the impulse signal. So minus of impulse signal also there. You can say 2 of t, you can say 2 of delta t. Okay, so these two types of signals you can use, or this is for the continuous time. Look, besides your continuous signal, you have to know the discrete. Though in your syllabus, this is in this topic, particular topic, continuous only prescribed, but you have to know this discrete also. Just same things is there. Just we will change the n. Instead of t, we will change n. You instead of t, we will change that n. Instead of delta, we will change the n. So it will become discrete type. Okay, just we have to say this is the n, and 2 delta equal to n, 2 delta n. So this is the discrete, and these are called the test signal. These are called the test signal. So what is the test signal? We have to test it. So first, say this example is there. If yt sine t into xt. So how could I check this is a invertible or non-invertible? Can't understand this. So yt equal to sine t dot x of t. So we can put this or this signal anyway. So we can apply apply xt equal to impulse signal. This is impulse signal means just only for t equal to 0 it is exist, otherwise we will just delete it. So just we say that this xt is the this signal we are applying this. So what happens? So y of t equal to sine in sine delta t, and that is t, sorry, this is multiplication, this is not delta t, because signal is only t, but you know this delta impulse signal is means when t equal to 0 it is exist, t equal to 0 it is exist, otherwise it is 0. So when equal t equal to 0 you have to put t equal to 0, sine equal to t equal to 0, and this delta t just t equal to 0, otherwise it is 0. So sine t value is only 0, sine 0 is 0 into this delta t, it is giving you the 0, so giving you the 0. And if I apply this 4 xt equal to 4 delta of t. Okay, 4 delta t, because we can say this multiplication, amplitude multiplication, so we may use amplitude multiplication, though its value became 1 2 3 4 up to 4 unit, but till now it is only t equal to 0, otherwise it is 0, otherwise it is not exist actually. Okay, 0 means not exist actually. So if we put again, so what happens? You can see this t equal to 4 delta t. So here we can get y of t equal to sine 4 delta t. So delta t means impulse function, and into this impulse function 4 delta t. Again, this t is applicable is at the sine 0. So sine 4 0 means that is also a 0. So it will given 0 into this 4 delta t, it is 0. So you can see x equal to, when x equal to delta t impulse function, then also y equal to 0, x equal to 4 impulse t, y equal to 0. So from this statement, and how could I decide that it is a invertible or non-invertible? Please tell me. Vishwanath Mardi, Mohammad Mahfuz Alam, Nikhil Singh. Please tell me, is it a discrete function or not?
Yes, sir.
Is it a discrete function? Sorry, is it a invertible or non-invertible? What? Bolo bolo. Is it a invertible or non-invertible?
Invertible, sir. Invert.
Invertible. Someone told invertible. Please just remember the statement. Just remember the statement. Once again, I am telling you, if each distinct input has distinct output, then it is invertible. Or if there is a system is designed, a system design is possible if we do inverse, then we get the original input. Or if there is a x set and y set, if 1-to-1 mapping is possible, means x1 equal to y1, x2 equal to y2, these three condition, any of these three condition, it is satisfying. Sir, please remember this thing. We put first time input. we get output that is 0. Input is only del t, means impulse function. Input is 4 del t. Something is changed. Something is changed. But output is not changed. Output is not changed. It is equal. So why this these conditions are satisfied, that x1 has the y1, x2 has the y2. Here x1 has the y1 and x2 also y1, or whatever you may say. If x1 is the y2, then y2 x2 is the also y2, because these are the same. If you put over here, that is x1, that is x2, that is y1, that is y2, but you see that y1 and y2 are same. So these are mapping to other, not one to one. That is, one input is mapped to the two output, one input, and this is the map to the this. So is that a invertible or non-invertible? This is non-invertible. Invertible because only one to one map there, one to one map, one to one, one to other is not possible. Then only this is invertible. Okay. So this is the test signal we used. Another example. Let's see the another example. Look, this is y of n equal to x of n product of x n minus 1. Okay. Say input is applying input is u of n. This u of n equal to input is u of n, means x of n we put u, instead of x of n we are putting unit step function. You know that unit step, 2 unit step are possible. So our system became y of n. Look, this is a discrete function. This is a discrete function. That's why instead of t we are using the n. So u of n into u of n minus 1. Okay, u of n minus 1. So it is answer another, and applying input minus of un. So what happens? Look, you just remember the output. This is y1, x1 we are doing over here. x1, what is this? That is u of n, and output y1 equal to these things, y of n product of u n minus 1. Okay, and we are applying x2. X2 is minus of un. Then what will be the output? We apply this output. What will be the output? U of n equal to minus of 1. So this is minus of un. Just put this minus of n. Very simple. Okay, multiplied with, again this is minus of un minus 1, nothing else. Okay, what will be the product? Product will be, what will be the product? Product will be this minus became plus. So u of n, we can say that is u of n minus 1. Ultimately this. So u of n minus 1. So guys, this system a invertible or not? Just tell me, it is invertible or not? Ashwin Kumar Mahato, Nikhil Singh, Sachin Shah, Saket Kumar Mishra, Sudhanshu Rajan, Taroknath Mahato, Raman Pradhan, any of you, please tell me, is the system invertible or non-invertible? you got x1 in, then you got y1, and that is the thing, and x2, that is the difference, but you get the same value, so it is not given that one to one mapping. One to one mapping is not possible over there, because x1 is also mapped with y2, and x2 is also mapped with this. So this system this system this system is not invertible. Okay, this system is not invertible. Now next topic is our stable or unstable. Next topic is topic 2, that is whether the system is stable or unstable. Stable and unstable system. Look, in your control system you have seen there is a criteria that ct is given, that ct at tr means transient response, plus ct that that is coming ss means steady state. This is for steady state. This is the total response. If a response is come and this is a transient response, transient response, and this is a steady state response. So here here only, if the transient response is going to zero, it tends to zero, or whenever it became reached to zero, then this system became only steady. So then only this is a stable system. If this transient response is not going to the zero, or not became zero at any more, even if it going to the infinite level of value, then this system will be unstable. Okay, so whatever may be, say this is the transient, so something maybe x y, this type of these things, if there is a plus, so it will going to the infinity, and if there is a minus, say this type of things, then it is going to tends to zero. Okay, then only this system will be stable. So due to stability, your this portion should be lie at the negative direction, at the this root, or these things are lie in the right left hand direction, so that this system became stable. Okay, if this system is at the positive side, then it will be, say this is oscillation. If this oscillation to the power, this power is positive, then it will going to bigger. But if this is negative, then your from bigger oscillation is going to less than then it will going to the zero, tends to zero. So this is going to the stability. This will be stable and this will not be stable. Okay, so what is the conditions for being stable or non-stable? Look, the conditions of being stability or non-stability is whether the input and output is bounded. Okay, the system is bounded input, bounded output. The system should be bounded or bonded. It is called bounded. Okay, bounded input gives you bounded output BIBO, then this system will be stable. We don't understand what is the bounded, what is the bounded. So we will go for an example. If there is a glass jar is there, if there is a glass jar is there, just remember the situation. Big glass jar is there. Here is some ball. Here is a ball. If this type of cup or glass is there, this type of cup or glass is there, In here you put some ball. Okay, you put some ball, or something is there just like this, uh, just like your golf ball. Golf ball, this type of ball is there, just hold at a at this position, or you may put in this type of ball is put over here. Just remember the situation. Say you apply some force, what amount of force, whatever you put some amount of force, but this should be bounded so that it this jar will not broken, not to be broken, not to be broken. So what will be the conditions of this ball? Please tell me what is your idea? If I lock this lock this position, okay, this is a jar, it is locked over here. You put externally, it may be this way. You may be you may just fall it, you may fall it over there. Such type of force should be there so that it will not broken. You may change the position, you may change the, I'm going for the next slide. you may you may put this jar. Just remember guys, just tell me what it may be. This condition, force, this is force. F is applied, then it may be over there. Okay, just way, again this position, again this position. What about the ball? The ball is moving here and here, moving here, but it never go out of sight, out of this, out of. Okay, so this is the stable. Okay, so it will. This is bounded. This is bounded. We say bounded input, bounded output. Look, we are applying such a force that it will never broke. Okay, so broke, whatever force is there, the ball could not out of this bohem or out of this jar. So bounded input and bounded output also there. Now in the second case, say this is your glass, this is your glass, or any ice cream glass is there. In here you put some, you put a ball. You may force over it. You may just you may just put it. Is there ball saying staying over there? No, your ball will going to out. So up to this level, ball is at the stable. But whenever it will cross this level, whenever cross this level, or you may slightly incline this, or you may slightly incline this. Look, up to this level, your ball remains stable, your ball remain bounded. So first time we are same, this is bounded. Bounded input, bounded output. This ball, this force is coming, this is so that it will not go to the break this position, but no need of this, because this side are open, so this ball will going to out. So it is not bounded output, this is bounded output, no, but force is still, now this force is bounded input. So is that a stable? No, this is critically stable. Critical point is that this point. So up to this point, it is critically. But if sometimes more, more, more inclination is there, then it will be output. So it is critically bounded, bounded or stable, because we say if bounded input if we apply bounded input, then we will get the bounded output. So it is, some conditions is there, this conditions is the critical condition. Yes, up to this force, which is this force is, this is called critical force. This force is up to this, then it will be bounded. But if we force, critical force is greater than the force is greater than this critical force, then it will just incline this, then it will go out. So it will not bounded then. So it is critically bounded. But something is there, which is just like your golf ball. Your golf ball, there is a golf ball is there. When golf player are putting or some this type of golf rod is there. Golf rod is a golf. Just remember the golf rod. Okay, it is just hold on this. Once you just put a force, just if you apply a some force, then it will be going to out. If you more force, then it will go anywhere. We don't know what will be the output. Okay, so it is, though it is bounded input, but output is not bounded output. So in this case, this is not stable. This is always static and just instability tends to instability. So this is your system. So the bounded, unbounded, I think you can understand. Okay. So we can say a system is a system M is said to be stable if it following following bounded input and bounded output. Bounded input, bounded output criteria. Okay, a system is said to be stable if it following if it is following the bounded input and bounded output criteria. So you have seen in this the poem with the ball, this is fully stable. You can say this stable. This is the uh, ball in your ice cream glass, or maybe another something of a glass is there. This is critically stable. And if this type of ball is there, this type of ball just holding on a, it is also called pin. In then it is a just a golf ball, GOLF golf ball. Then it is just like the unstable, unstable, because the stability is not uh, staying enough for few seconds, until unless until until no force. If a few amount of force is applied, then it will be unstable. Okay, so this is the thing. One thing, uh, this is the condition of the stability. And guys, so we can also just write down any input, any input is finite, finite, then it is bounded. Okay, any input is finite, then it is bounded. Any output is finite value, finite, then it is also bounded. So what is this thing? Any input means it must greater than or equal to mod of xt. Say mod of xt, it is less than, always less than infinity. And what will be the output? Output will be also less than or greater than y of t equal to, that's less than equal to infinity. So within this infinity lemon, say we are applying 1 lakh, 10 lakh. Okay, then also it is bounded because we can determine. But if we don't definite it, means undefined functions, then it will be the unstable functions. Okay, uh, say say this is the impulse function delta of t is impulse function. So it is bounded because this is only exist as it is only exist at t equal to 0, otherwise it is not, so it is the bounded. So what will be the output of this? If I put this first pulse, then you can say output will be gradually tends to 0, and after then it will 0, because once it is going to 0 and this is 1, say this is 1 to 0. So if it is 1, output will be 0, but not all of a sudden, it will gradually going to, because this is a continuous function. Okay, continuous function, this is gradually going to the 0. So this is the things. Or we may express this integrally, because if we integral this, then it will be minus infinity to plus infinity h of tau, this is called tau, and d tau, it is less than for continuous. If it is discontinuous, then only output will be the same. But if this is a continuous, then continuous it is going to. Just like this, if your signal is going to 0, this is 1, this is continuous. But it in your this type, okay. But if we discrete, then it will be just come over here. Yeah, you have to come over here. See, just put it, just come to over here. Nothing 0, nothing else. Okay, so this is your bounded signal and your definite signal, or you may say this is your stable signal. Okay, so today is only 1 minute left. Next day we will go for an example, so that you can find out what is this is stable or not. Say y of t x square of t, then why this is a bounded or non-bounded, tell me. Okay, yeah, system is stable or not stable. Okay, so this type of example we have to perform, so that we can find that is stable or non-stable. So so guys, thank you for the day, and time is less than 1 minute. Okay, have a nice day. So I stop here. If you have any question, you may ask me. Otherwise, I am going to stop. Okay, thank you.